I'll let you into the secret. I don't like to talk. And so how I got into AI is actually automating myself as a speaker during COVID because it was no fun to talk. So I'm happy to be here again at the live conference. So maybe I'll do something else in between. From ChatGPT to production, let's get started. Who has seen this amazing kind of speed of delivery of OpenAI? Right? In 1 year, most of people know the chat, but they have the plugins and much more features, and it's at the scale they're operating, it is pretty insane. I don't think we've ever witnessed that. I haven't witnessed that in my lifetime, the speed and the impact that this has been given. I don't know whether it happened to you, but in our company, people were very excited about this. Kind of product says we can do all the things we always wanted to do with the product. Marketing says we can kind of market the hell out of this. CXOs all were about, we're going to make money with this. And the engineering said, damn, how do we make this work? We didn't see this one coming. So I'm glad to see a lot of data engineers in the room. And this is the journey that I'm trying to explain how we learned over a year to kind of get things into production and to make it a little bit working. I'll be honest about that. So I'm Patrick. I try to be an independent voice in the industry. People have said I was there from the beginning of DevOps. That's 14 years. I totally got bored with DevOps, and I'm sorry about that. But this reignited my fire again to talk about this because it's a new paradigm. It's something that I do want to understand, and it will have an impact. I'm currently working as a VP engineering at Showpad, and part of this is actually a story, but also hearing from others on the same journey. Showpad is sales content management. It's irrelevant. Most people don't know it, but I want to show you a few of the features. One is we wanted to have a better search, better than keywords, because it's messy if you're dealing with organizations who have multiple languages and kind of multiple concepts. Taxonomies is hard to do, so we needed a better way to kind of find things in the whole stack of documents and content we have. The other thing was we had so much content, people are bored of reading, so we created summaries somehow with AI. And then from all that material, news, sales, and marketing people need to be trained. So creating tests was also very intensive. So we're trying to use AI for that to create tests, questions, and answers. And it is pretty hard to actually create bad answers. Good answers is easy, but bad answers is actually hard to do. Bad answers that are relevant for the material you want to do. It just gives you some ideas on the things you could do. We're going to go through the same motion as we know with DevOps. We're going to build it, we're going to deliver it, we're going to operate it, and then business as usual. This talk is about how DevOps can help deliver GenAI better. The next talk is about how you use GenAI to deliver better DevOps. So I'm deliberately taking another direction on this because I feel this is the story that also has to come out and not just about our own productivity there. So to build things with GenAI, I think there's 5 building blocks that are relevant. The prompt, which is the thing you type in your ChatGPT. We've already seen this in the previous intro. The model that you use, most people know the GPT model. It's in the name, ChatGPT. The data that you're going to put into the model to train or to enhance or to use it. Hook it up with APIs to do more interesting things than just data retrieval, and then somehow cobble all these things together with an orchestration framework. A simple slide, not really, but it shows you most people use a simple question and answer in ChatGPT. We've already seen, things like act like your life depends on it. That's called a system prompt. Makes it a little bit more efficient. And you can give examples, what you want to have. Like, do this, here's 2 examples, give it that. So there's a whole chain of different things of prompts, techniques, or patterns that you can use to get better results just from that single prompt. But it doesn't stop there. If you want to integrate this into your own apps, you also want to say, I want this as a JSON file or an XML file. And sometimes it doesn't give this quite right. So you may validate this with a schema, another step. And then if it doesn't work, you want to retry and see if it works. So this is the reality from the simple prompt kind of making it more kind of efficient, but also a lot more complex on this. So we learned this, that it's not one prompt, it's a sequence of prompt. And the things kind of slow you down. So you would think that one question answer is slow already with ChatGPT. Imagine if you have to do 4 or 5. If you're putting that in the hands of the user, they're just going to put the reload button, right? So definitely something to put out. If you can cram things as much in one prompt, that's efficient, but sometimes you just can't. And adding a comma, a line space, and enter, it just changes the behavior. So it's very finicky with this. And to get it even further, it actually depends if you go from GPT-3 to GPT-4, it all changes again. It will give different answers. So this is, I guess, the most brittle part in this whole thing, which is the English language, and not just about being kind of grammatically correct. It's kind of understanding what actually the model wants you to type to get the right result. So there's a lot of work that goes into this. So that I would say is the first part. The second part, most people know actually on the GPT model, but there's been an explosion of models, of foundational models. Kind of Google went for the BARD, AWS now has their own on Titan, and it just keeps exploding and exploding. And they all have different ways of dealing with things. They have all been trained differently. But one of the things is we on the journey, we started with the early ones because GPT was not available to be run in your own kind of environment. But gradually, these things got better and better and better. And now we're up to a point that we can just use a service that is not just a GPT, but it's like Claude or AWS to run with it. So be aware that there's lots of them, and it just keeps evolving. And then I would say open source is actually catching up a lot faster than we thought of. This is thankfully due to, whether it was intentional, yes or no, a leak from Llama, from Facebook, who leaked their model and then kind of made it open source. And people have been enhancing and working on that one as well. And the interesting part is that now it is a viable option to run an open source model. A year ago, it would give results that are not satisfactory to be used in a business. So we kind of got a better thing. The nice thing is of Hugging Face is that all these models, open source models, are actually available. So it's kind of like a GitHub, GitLab, of models available that you can just download and use and run at your own convenience. What is interesting is that most people come to this, data engineers that come with it like, oh, training the model, training the model. What we're seeing here is it's not about training the model. It's just about using one of the other models. Maybe you can train it, tune it later, but it's definitely the first reaction is you can just use an off-the-shelf model. And there's a limitation by how many characters you can put in a prompt. And I think even today, the SaaS providers are not up to a production quality level SLA. You cannot have a guaranteed response time. You cannot have a guaranteed capacity plan. Yes, they will tell you need to allocate and pre-reserve your things, but that's not cloud, right? It's still going back. They're still all struggling with this. So that's one thing, making this more operational. The other part is you see kind of different models. One is we own a foundational model. We're going to serve it. That's kind of Anthropic, Microsoft. Then there's AWS who starts acting like a broker. They're just saying one interface, you can talk to all of them. And then there's the third one, which is Hugging Face. It's kind of like run your zoo, download your own model, run it on one of the platforms as you've used to run your own models there. We started thinking about the models in a way that some are cheap, some are expensive. So much like you label your data like a bronze, silver, and gold, we started thinking about a certain use case only requires this kind of quality. This would be really gold because it has a big impact on the user. So that is another thing, kind of balancing between cost and functionality there. And then finally, when you pick your model, check whatever license it's using, whatever it's been trained on, whatever toxicity or kind of thing is there, and read the fine print, whether they are training on your model, yes or no. It was only, I think, after 6 months that ChatGPT put the option of being anonymous, right? So they got 6 months worth of the world sending data without having that. Speaking of privacy, what everybody wants is to use their own data, but not have it land in the large language model themselves. So there's a pattern for this, which is called retrieval augmented generation, where inside the prompt you normally type, you put pieces of documents that you want to have the LLM use for the solution. So this solves part of the privacy model in a way that you don't expose all your data, you don't have to train all the data, but you're sending it to pieces. And the way it works is that, imagine you have all your text documents, all your material, you cut it up into pieces, and you index the pieces based on kind of what the text is about. That kind of what the text is about, we call that an embedding, and it's like a vector in a very big dimensional space. That vector we store in a vector database. So in a lot of the cases, what we're doing, there's a new infrastructure part that we need, which is a vector database. And it's basically finding, I have a question, I will look up in the vector database which are the pieces that are relevant to my question, take those pieces for the answer, send that into the prompt, and have figured out what the answer is. So this is kind of a little bit of the technique that you can do to bring your own kind of data into that. People have been talking about fine-tuning, but I would not do that as much as people think you want that. Because you could solve a lot with the RAG, and it's a lot more flexible, and it also solves things like privacy, because it is at runtime, it can do access control, who gets what data, what is injected there as well, and it's always in real time. If you would fine-tune or train your model, it's always outdated. So you cannot use that as well. People sometimes would think you need a special database, but all the traditional database vendors are working on storing vectors in there. So over the year now, we've seen kind of the Redis, the Elasticsearch just catching up, and it's a way to store a vector. It's not that complicated. So we'll see an emergence there as well. So to make this happen, you better have your data in shape. So data engineers, do your job. And it is very useful to have the data as an API. If you want to integrate it, don't use a batch shop to copy data over something. No, have it as an API. So if you want to prepare for that, that is the most useful thing you can do. A lot of companies are taking kind of off guard is that they only have focused on structured data. But documents like text, a Slack message, they're all unstructured. So you need to think about getting those pieces in there and also cutting them up intelligently. So it's not just like every 100 bytes, but you kind of go like, oh, this is the end of the message, or this is the end of the chapter. So kind of cutting these things up. So use RAG, that would be my recommendation, as much as you can, because it helps with privacy, real time, and also access control. I think we're now at the fourth piece. API and agents. This is where we're heading towards, but I haven't seen a lot of people get up to that point yet. And to be honest, because we haven't got the previous thing well working and under control, this feels very scary to have things execute on our behalf. We know it's the future, and it's less about having that one prompt. It's you give it a task. I want, an essay written on this with that data, figure it out on the internet, find all the sources, pull some data in from my own, start a workflow, ask approval, that kind of stuff. That's what we're heading towards, but it's still quite soon in the industry. So the difference to get that working is also stop just sending events or event stream of clicks or things that are doing. You have to capture the context. Why did this happen in that meeting, right? If you want to have good knowledge. Who were attendees in the meeting? Like, what was the meeting description? It's not just somebody clicked to start meeting, stop meeting. There's a lot more that you want to capture. And that's a lot more complex than most of the activity tracking that I've seen in companies. So it kind of works, but more security is needed. But we know this is going to be probably the differentiator in the future. And then to couple all these things together, you find a framework like LangChain, Llama Index, or Semantic Kernel if you're on Microsoft Stack. And they pull all these things together. They take your prompt, they make it a template, they make it reusable in your code, and then you can have it load data, you can have it chop up data as well, and you can do the routing, like, oh, maybe for this one, you go to that model for a question. For that part, you're not going to a model, which is a lot less costlier. So this orchestration layer really helps. And it's also an abstraction layer like you would think of, instead of going directly to an API, that you can work with multiple models, multiple kind of data interfaces there as well. But again, they change so fast. It's incredible. I think the LangChain, I think the README and the whole structure have been rewritten probably 3 times, a major big rewrite over the year. So whatever code you're writing, you gotta have good tests to actually deal with this, because otherwise, you don't know what to expect the next day. I try to give lessons about this. It's the fact that I have recorded the output that I can able to do the lessons, but otherwise I would never do this live because I don't know what this would give me in reality. The other thing is they're still Python centric. This might cause friction from standards because most companies have maybe Python as a standard in their data, but they don't have it in their engineering, in their applications. So there's a little bit of friction kind of coming there, and also people then having to deal with all, how do we do observability in Python? How do we do the load testing in Python? So there's a lot kind of learnings there as well. So we got all the pieces on the board now. Now we want to deliver this. And much like, think about this as like 5 dependencies you're trying to deliver towards production. Probably the easiest one is the model, right? It's a binary file. You upload it to one of the systems that you already have to run a model, and that's done. It's there. It has an API. Mixing in data, we already talked about this. Data, if you put it behind an API and you have a good version of that API, that is probably also quite easy. Then I would say the other 3 parts you usually deploy together either as a container or a serverless. Why a container still and not just completely serverless? There might be some models that you have to bundle inside of your application, which hit limits on Lambdas, which have cold starts, again, to load these things. So you might be better off with some containers there as well. But as such, it is deployed as we would do deploy code. It's just that instead of having a file which is an image or code, we now have a file with a prompt. We could theoretically deploy prompts separately and just fetch them from another store, but most of the people actually deploy the prompts together with the code and with their API. But if you want, you can do A/B testing just on the prompts only there as well. So have that out there. The real difference is the kind of the deploy speed. The left one was supposedly easy because it's like code deployments and it just goes through your pipeline. The other ones might take longer to load. They're bigger files. It times out sometimes in your CI system. But in reality, what you really want is to have integration testing, because the pieces by itself, they don't mean that much. So you have to look at it like end-to-end testing is what you want to go through. Like if you release a prompt, it might change a lot of things. If you change your orchestration layer, it might change. If you change another model, it has an impact on the prompt. So you have to do your testing across there pretty much. And for that testing, for most people, that's the weird part. So imagine I'm writing the application that creates questions for the quizzes that I mentioned before. How am I going to write the rules? What is a good question? It is not a perfect thing. Like I can say the length of the question needs to be 15 characters. Of course, I can do that. But does it make it a good question? Is it non-toxic? We don't know. So you get into a whole new ball game of what does testing means. Some of the testing, I think my team early on, they were all testing manually. And they were using the phrase, who's the king of France? And then they would check that, what it was given. But obviously, we don't want manual tests. It's very expensive, we know that, and all the time. So doing more automation is key there. So what you do is you create a test set of your question and then the result. And the result went through, kind of your whole 5 pieces and gives you that. And then you measure end-to-end that answer. You can check for things like, was it relevant to the question? So that's one thing. Was it toxic language you could test? Was it actually an answer and did it not return gibberish or something? So testing those things, we found there's 2 approaches. There's one on language. You can use some NLP techniques to kind of see if there's a relevance on stuff. The second part is there's now specific models, like smaller models, not large language models, who have been trained for specific tasks. Is this toxic? Yes, no. We can have a model that is being trained on that. So we test that kind of thing when it comes back. And then obviously we can say, well, this is the input, this is the output. And then we tell the LLM, imagine you're the best tester in the world. Here's the input, here's the output. What do you think about this quality? So that's the third one. It is a pretty expensive one because trained models go a lot faster and this still uses your prompt, but is another way to scale this. It is scary that we're using AI to validate AI. It is there, but it might be the only way we're able to scale ourselves around that problem in the end. And so some companies offer this feature and they have like an LLM specifically trained on these kind of tasks. So that's another industry spinning up for the other industry to deal with this. So like I mentioned before, same principles. Getting GPUs might be hard in your test environment because they've always been reserved and they're not that easy to get right now. The model pipeline is slower, but testing is key, and automate your testing with one of the principles that I mentioned before. And so capturing the input and output from whatever you're writing is important as a thing. And I think Amazon is coming out with something that actually allows you to grab all those inputs and outputs and then have people review this and then pull them into your test data set of your own application, not just of your model, but also of your application. So imagine we are in production. We need to operate that stuff. You see the whole stack is getting bigger of things that we need to look at. The vector database is one, the infrastructure was already, we're used to that. And then the models, large language models, and then LangChain and the whole stack. So we need a better way of dealing with that stuff. So the traditional monitoring vendors, they will tell you, yes, we have LLM monitoring, GenAI monitoring, but they only have kind of the traditional ones. Throughput, how much it costs, because this is easy for them to integrate. But we want things like time to first token, much like we are in the front end. How long does it take? The delay there. And the latency I already mentioned there as well. So these are a few things that could probably easily add that, but it requires a little bit more instrumentation. And every language model kind of does it differently in that way. But what we really want is continuous data quality monitoring. So remember that test set I had you create during the CI/CD process? Run that continuously in production, like a health check that goes in and out. You use the same methods of dealing with kind of the quality and observing that quality. And then you alert on this. For example, if you're using OpenAI and they switch or they change something on their model, you wouldn't know, right? But this is the way how you start dealing with that stuff. If somebody changes the API, if some, all of a sudden people are doing creative prompts, this is also a way of testing the quality in production. And then we can also start monitoring PI security metrics because it's basically an output text. So we can watch that output text and we have models that are trained to look for PI. It could be a regex, it could be more. We have models that have been trained on prompt injection. So those are another metrics. So the tools actually work by running these models on your own premise while you're executing. They're pretty fast because they're trained models and they don't have the latency problem of the LLM. And it also allows them not to have them send them data because all data stays locally in there. So have a look at Y Labs. I think they're on the far front of making this a better reality. And then there's a new thing, we're going to have WAF firewalls because why would you have all developers check that in their code? Why not just put a proxy in front of what goes out, what goes in? So that's another thing. So I think like a WAF for LLMs. And then there's caching because we don't want to go over the wire all the time for the same question that customers are asking. Maybe we can remember that we know what is similar, what is related, so we can use that same trick for caching. If this query was similar to that query, we're just going to give the same answer back, and we don't need to have the trip back to the LLM. And then much like we have spans or tracing, we now have this whole chain, the one prompt to the next prompt to the next prompt. So for debugging, you'll need like a trace across all those queries and see them as a session or as a transaction. And then hopefully you also see which API calls they're doing, what data comes back, what has been checked, what has been stopped. So there's a whole new field emerging of this traceability to get a better understanding what goes on in production. And there's of course other ways. Do the people actually like this? And do they accept the answer that we give them? So imagine you generate an email on behalf of a customer. You can have them thumbs up, thumbs down. That gives you kind of a sentiment, was this good and bad? But I guess nobody does a thumbs up, thumbs down for that. So you can think about it as like, oh, we're going to create a copy button, because if there's a copy button, maybe they liked it, so we know it's being used. And then we can also have a try again button, regenerate the email, because then we know that we're not happy with the previous ones. And then we can have them an editor directly, instead of having them copy it and then edit it there. If they edit it in our platform, we actually know like what parts were rewritten there. So if we capture all that context together with our data set that we're capturing, we can actually listen better to the customers and their signal there. So it very much feels like we're doing this in prod. We don't know, because people are giving prompts and data. We don't know all the data customers have, and we're mixing this in. So we'll have to monitor in production. We cannot stay as traditional in data. We do our test set. It's like scrutiny in our test lab, in our data lab. We have to monitor production there as well. So this got us operating. Next part is business as usual. We're running this. So maybe the part that ties the most into DevOps as silos and cultural shifts is that data engineers cannot stay in their data lake. They have to move towards production. And it's not something they're used to often, to be in the middle of the attention and be in the engineering field of directly to the user. So what we've seen is that it used to be two separate pieces in our company. We added a little bit of engineering in the first team that was doing the kind of the delivery. Then we flipped it around that they're becoming like more of a trainer of the engineering teams. And then part of the infrastructure across all the teams, we've moved into the platform team. You could call that the data platform team, but there's probably things across all the applications teams that you're going to put in. So even your platform teams, I encourage them to look into this and to start kind of be on that journey. Again, it's amazing how easy we've made things for data scientists in the cloud to run how they want and so on. But it is way better if they're aligned with all the rest of the company on doing that stuff. And so for me, it becomes like continuous integration, continuous delivery. But every time a new technology comes around, we are re-architecturing things. So that is basically, if you got CI/CD covered, the next thing is how fast can you instill a new thinking model in your company? That is kind of where we're going to get faster and faster, something that is being disruptive. So this was the organizational part that was shifting. It's interesting, I am not a data science person, but now I feel this is an integration integration game. And I'm used to dealing with uncertainty with my ops background, and I feel very much at home kind of trying to make the best of this new world. But that's obviously not enough. You also have to earn the trust of the customer. So they will ask you, what are you doing with our data? Which LLM are you using? Where are you sending that stuff in? So get ready to write that up. And there's usually a marketing version of this, a legal version of this, and also an engineering version of this, because they're all different audience and they need to have all these things covered. And in the beginning, we got a lot of questions like, can we opt out on this AI? We're not trusting this. But remember, opt out is like creating a fork in your code with this. If I improve search, and I think the AI-powered search is better than the keyword search, if a customer opts out and wants to use the old version, I have to maintain 2 versions of that search. It's very costly. So be aware of that hidden cost when you do opt out. So try to be firm in the beginning, get that trust, show what you're doing, but kind of deal with as much as you can and reduce the exceptions there. We've also learned not to hide AI. It's very, a lot of people say, well, you know, if we can do that magic, they don't need to know. Well, it is not perfect, so they better have to know that it's not perfect. So almost embrace this by, you know, we use a different color, we put a sparkle on our icons, we kind of slow down the text even more because it's being generated. We make all those cues in our UI to kind of show this is AI being used, use with caution. So it's embrace actually that it's not perfect. And then when you're selling this, it's going to cost you right now a lot of money for all this out. Not on your trial, right? You can do this, but in our case, all those documents, imagine we'll have to scan them. New technology comes again, 2 months later, scan them again. There's a lot of tokens flying over. So you better start thinking about how you're going to absorb that AI cost in your pricing. And if there's one thing I learned over the years is that changing pricing in a company is very hard. Why? Because it's often very hard-coded in the product. So one of the ways to do it is to kind of get to metering. They buy a bunch of tokens. It's like your company's tokens. It's not like LLM tokens. But that gives you the leeway of the ones who use a lot, they are charged a lot, and the others are charged less. and get your budgets going. It's about the time of the year. Some say that budget will require about 20% of your kind of compute spent on AI if you're going all the way. Again, your mileage may vary, but it is a good time to think about it right now when you're kind of proposing those budgets. Speaking of budgets, multiplied by a factor, which I call the innovation tax, because we are doing these things re-architecturing over and over again. And we do expect the pricing to drop because we're at a high and it's like a special thing, it just comes out, but we don't have volume prices in a good way yet. So sometimes do-it-yourself is still kind of cheaper, but I guess once everything gets going, it's going to be a lot cheaper on using a vendor. But right now, the fact that you're kind of doing this new technology, throwing it away, it becomes a product somewhere you can buy, and you just churn through that, is going to cost you money, but that is innovation. And you should also already think about the differentiator. These things that we're building now ourselves are going to become commodity. They're going to become part of the fabric. Us doing all the monitoring, the firewall, they're all going to be part integrated. But you do have to start your journey now to understand this, because you might be too late on your journey. And that's actually the advice Damon Edwards, a friend of mine, gives. So he compares that the web kind of, us writing HTML websites is going to add some cost, but we can do more business. Mobile was the same. AI has the idea that it's going to be, now there's going to be spike of cost, but we're hoping, again, to even save a lot more with those costs as well. And you better get started, because your competitor already has, and a lot of companies have been telling me, we were late to the DevOps game, but we don't want to be late for this game. Right? So if you don't start your trial and error right now, you're going to be behind whoever's already doing it right now. And this is kind of my closing tweet. I get excited about this. It's a lot of uncertainty, but it's an amazing time to be alive with this. And I thank you for listening. I hope you find me in the hallway, because I don't really like to talk. The only reason why I talk is to hear other people's stories, right? So tell them to me, whether you're on the beginning of your journey, you're further along, you need an extra, listening pair of ears, contact me. And for the rest, I wish you a very good conference. Thank you very much.